motor starting methods. I'll just turn my brush on here. Okay, turn that off. So why do we have motor starters on our three-phase motors? Okay, when a motor is switched on, we get this massive inrush current. We've talked about this before in class. I just want to find you a picture. Here we go. This is kind of what's going on here. So here's time, current. So we turn the motor on, we get this massive peak, goes up to this point up here. It's what we call the peak starting current. So it's just gone off screen and it comes back down in time. So how quickly does this happen? It happens very, very quickly, okay? And it depends a lot on the load on the motor. If there's a big load, that may drag on a bit longer, but it's such a short time that we don't really have to think about it for when our cable sizes, but we do have to think about it for the equipment we put on it. Okay, how big's this? If you look at this here and you compare to the top there, it's probably 5 to 8 times the running current. Okay, once our motor's running, our power output of that motor, the starting current's about 5 to 8 times. So the whole idea of having starters is to try and manage this. So let's have a look at that. Let's go back here to here. Excellent. Okay, so this high inrush current can cause a volt drop and may affect other services. You may see that your lights dim, or there might be some electronic stuff, some computer stuff may drop out or something, because this if big motor coming online, it'll pull the voltage down on the lines and it'll affect other services. Okay, and these other reasons suppliers may enforce. You may have an agreement with your supplier that they say that big motor, you may have to start at a certain current or even at certain times for big motors. Okay, and there's stuff in our wiring rules, and it could be beneficial. Some of your power contracts may be based on peak load. So if you've got a motor that's pushing out a massive peak, it may push up your power bill, okay? And by managing our starting currents, we can reduce the size of switch gear, etc. Not so much cables, but definitely switch gear. Okay, here's some methods. Direct online, star delta, primary resistance, auto transformer, soft starter, variable frequency, and slip ring motor starters, okay? Also known as wound rotor motor starting. Direct online starting is what we've been doing now up to now. And when we're in the labs, we built our starters, we put our control circuit on, our contactor comes in, the motor starts up, there's no other control in place, okay? It's just what we call direct online starting, and it'll come straight on at full starting current. We're going to go on today. You're going to look at building a star delta starter, okay? And we're also going to do primary resistance. Those are the 3 starters we're going to do, but we're going to look at how these other ones work. Let's have a look at direct online starting. Okay, it's the simplest and most cost-efficient method of starting motor. So all we've got to do is all we need is a single contactor at the minimum, just one single contactor, maybe a motor overload and isolator. Turn it on, the motor starts. Starts with a big draw and a lot of torque, okay? So the motor can actually jump. Sometimes, I don't know if you noticed, when we started them, they almost want to twist off their brackets, okay? So we're not controlling that starting current or torque at all. The only thing that stops the current is the actual resistance of the windings, that transformer action and induction, okay? So it's all just down to the characteristics of the motor. Okay, so right at turn on, massive induced current because the motor's not moving at all, so it's almost like it's got a short circuit on it, and it's just really relying on that resistance there and until it gets up and moving, and then that current will drop away. Must ensure that all the components, when are now direct online, our contactors and that are rated for these high starting currents. Okay, so the contacts on the contact, those currents will be going through it, so we've got to make sure they're rated up there. And we're also going to make sure the machine is designed to take the high starting torque. When I'm talking about the machine, what's on the other end of the shaft, It's going to start with a lot of torque, so if there's a load on there, you've got to make sure that that's designed for that. Okay, just the buttons and a contactor. So generally used when the power of the motor is low. So we use it on our smaller 3-phase motor. Does not to be sped up gradually, so it doesn't mind having it's just coming on full load at the start, and the starting torque can be high without affecting the machine operation or the load that's driven. Okay, so make sure the machine can start with a bang, with a lot of load. Let's have a quick look at the circuit diagram. We should be up to speed with it because we've used this enough. Here's one here. Here's our 3 lines coming in. Line 1, line 2, line 3. Just a bit of protection, overload protection, maybe thermal protection, all built into here. Our contactor, pull the contactor and the motor goes. It's our stop, starts, and our contact. This is the circuit we've been using a lot of. Our stops are normally closed, our starts are normally open. This one here's the latch. So we push the button, it latches. Control circuit. We should be able to play that. We've been using this control circuit a lot, direct online. Nice and simple. We're going to go on and we're going to look at star delta. I'm going to finish it there.